Okay guys, so we are going to continue on talking about electricity this week. I know we've been working on that for about the last week, trying to understand the basics of electricity and electronic principles. So today we're going to continue on, and the focus for today's lesson is talking about Ohm's law and understanding what Ohm's law is and how to use it. Okay? So, first question I have is, what is Ohm's law? So if we remember from last week's classes and videos, we'll know that Ohm's law is an electrical Ohm's law is a law stating that electric current is proportional to voltage and inversely proportional to resistance. So we can see our Ohm's law is usually exemplified or illustrated by a symbol that looks like this: E, I, and R in a circle. Okay? So let's go take one step back and let's remember what our three basic units of electrical measurements are. And we have voltage, which is this guy here, which would be the pressure of a water pipe. Amperage, which is the flow of water, the quantity of flow of water through the pipe. And then resistance, or ohms, which is the restriction or resistance to flow. Okay? So higher amperage or higher voltage is going to be able to push more amperage through a given amount of resistance, okay? But flow is going to be inverse to resistance, because the more resistance we have, the less flow we are going to be able to have, correct? So to calculate this, we have to understand what all three of these symbols mean. Now I want to let you guys know that our three symbols are actually scientific units of measurement, which we typically wouldn't see in the field. But I want you to understand what they mean, because you will see this either way, and you kind of need to know what that scientific meaning actually is. Okay? So we'll cover it briefly so you know. So our very first one is going to be E, which is electromotive force. Okay? And that is the same as voltage. So you can take that E and you can put a V right next to it and you would be just fine. Okay? The next one is going to be intensity, or amperage. So the I means intensity, which is how intense is the voltage. And I will always mean amperage. Okay? And then the final one, last but not least, I think everybody will know this, R is going to stand for resistance. So our formula is, or our Ohm's law is, voltage over amperage times resistance. Okay? The beauty of Ohm's law is that we can use any two of these results or readings to give us the answer for the third reading. So if we need to know what resistance is, we can multiply voltage times the amperage, or vice versa. So today we're going to start off just simply with one of these, and we're going to start talking about resistance. So to calculate the resistance, we must know the voltage and amperage of a circuit. So our formula for finding resistance is going to be the electromotive force, or voltage, divided by intensity, or amperage, and that is going to equal the resistance, okay, in ohms. So let's go ahead and do an example. So this is a pretty simple circuit. We have our battery or power source and a fuse switch, and it looks like a light bulb. So we know that we have a 12 volt power source and we have a 2 amp bulb. So how much resistance is going to actually be in the circuit? Well, with Ohm's law, we can calculate that. It's pretty easy. It's actually really simple. So we take our E, which is our voltage, and we plug that in, gives us 12 volts. And then our intensity, our amperage, which is 2 amps, right here, we get a resistance value of 6 ohms. So we know that if we had to replace this bulb and we didn't know what it was supposed to be, we know we would have to find a bulb with a 6 ohm resistance rating to replace that. Okay? That is it. It is just that simple. You don't have to try anything harder than that to be able to calculate resistance on a series circuit. Now, I am going to add one level of complexity for this, and we're going to add 2 light bulbs. Okay? Now, oh my gosh, 1 was easy. What do we do with 2? Well, it's really not that big of a deal. when we go from one bulb to two, the only difference is in a series circuit. Now, mind you guys, we're talking about series circuits right now. We're going to talk about parallel circuits in the future. That does make a difference. But a series circuit, when there's only one power coming out of the battery and one power going back in, that is really, really simple. So in this situation, we simply have to add the amperage from both bulbs, okay? So if we take our load number 1, it is 3 amps. Now all we have to do is add the load from bulb number 2, which is 1 amp, and that gives us a total amperage of 4 amps. So to find our total resistance, we take our system voltage, which in this case we can see is 12.5 volts, divide it by 4, which is our total number of amperage, and that gives us 3.125 ohms. So our total circuit resistance should be 3.125 ohms, okay? Alright guys, so I hope that helps. Your assignment today is going to be to do a couple of those calculations. And if you have any questions at all, please feel free to call me or text me, and I will do whatever I can to help you, okay? Alright, talk to you guys later. OB out.